Good evening. So the topic that I'm going to be talking about is the KNN algorithm. Here are the contents that will be going through this presentation. What is KNN? How do we choose a factor K? When do we use KNN? And how does the KNN algorithm work? So what is KNN algorithm? KNN means K nearest neighbors. This is one of the most simplest supervised machine learning algorithm that is used for classification. Okay, so basically KNN has two uses. It is used for classification as well as regression problems, but mostly it is used in classification. So it basically classifies the data point based on how its neighbors are classified. Then KNN stores all the available cases and classifies new cases based on the similarity measure. Okay, so let's take an example here. Here we have two wines, red and white wine, and we have a new these two wines, the red and white. These are known to us. These are labeled to us, and then there is you can see a white glass which is marked. We have to decide which wine is it. Is it red or is it white? So K in KNN is a parameter that refers to the number of nearest neighbors to include in the majority voting process. Okay, so what does this mean is the as the name suggests, K nearest neighbors. So the all the classification depends on the value of the K, what value of K you take. So let's consider, for example, here we have taken K equal to 5. So as you can see in the circle, the nearest neighbors, the five nearest neighbors are marked in the circle. Okay, so a data point is classified by majority votes from its five nearest neighbors. Hence, here the unknown point would be classified as red since 4 out of 5 neighbors are red. So what does this mean is the glass that was given to us to be told whether it is it red or white. So when we have taken K equal to 5, we can see that the neighbors which are closest to it are red and one is white. So since the majority of them are red, so the glass that was given, we will consider it as red. We'll classify it as red. So how do we choose the factor K? Now K can be chosen. K can have various values, right, beginning from 1, and it can go so on. So KNN algorithm is based on feature similarity, as we have seen. So choosing the right value of K is a process called as parameter tuning, and it is important for a better accuracy. So let's take another example here. As you can see in this picture, we are given squares and we are given triangles. So when you take K equal to 3 here, in the first circle, you can see that two squares are given and one triangle is given. So there are so this K equal to 3. In this K equal to 3, two squares and one triangle. So the new variable which we are asked to classify is obviously square, because squares are in majority. So let's take the next case, which is K equal to 7, and let's see the second circle. So when you see the second circle, so when K equal to 7, you can see that the squares are 3 in number, but the triangles are in 4 number. So what has happened here is, as we have changed the value of K to 7, the answer which we are getting when K equal to 3, our new variable was classified as square, but when K equal to 7, it is classified as triangle. So this is the reason, this is the reason why we should take accurate value of K, so that we get the accurate answer. So there are two methods to choose a value of K. One is we'll do the square root of n, where n is the total number of data points. So for example, let's come back to this picture again. So you can see the total number of data points are 1, 2, 3, 4, 5, 6, 7, 8, and 9. So there are 9 data points. So square root of 9 is 3. So here you can take K equal to 3 and you can get your answer. So generally what happens is we generally take the odd value of K to avoid confusion between two classes of data. So whether when you take a square root of n, if it comes out to be even, then you add 1 or subtract 1 from it, and you are good to go. So when do we use KNN algorithm? We can use KNN when data is labeled, data when data is noise free, and when data set is small. So what do you mean by data set is labeled? Okay, so here we can see a dog is given. Okay, so let's consider an example. where you have data where you have dogs, cats, and everything is labeled, so this can be known as label data. So KNN can be applied on the label data. And then the second comes is when data is noise free. As you can see in this picture, we have given weights and we have given the heights, and there are two classes, of the weight and which comes through the weight and the height, which is one is underweight and one is normal. And then we can see there are three noises: 140, 23, and Hello Kitty. These are the noises. So Canon can't be applied here. It can only be applied when the data is noise free. That means when the classes for these three, if the classes would have been underweight or normal, then we could have used the KNN algorithm in this. And when data set is small, the third place where we can use a KNN algorithm is when data set is small. Because KNN is a lazy learner, it means it takes time, to process the things. So if data set is small, then KNN is really beneficial and it is accurate. So how does the KNN algorithm work? So let's consider an example here. Consider a dataset having two variables, height and weight, and each point is classified as normal or underweight. Okay, you can see in the class. So we have given two values. Okay, of we have given one example. Okay, one question where weight is given and height is given to us, and we have to classify whether what will be the class of it, whether it will be underweight or it will be normal. Okay, so to find the nearest neighbors in KNN, what we do is we will calculate the Euclidean distance. So what is Euclidean distance? According to the distance formula, the distance between 2 points in the plane can be given by x minus a whole square plus y minus b whole square whole under root. Okay, so this is the formula of the Euclidean distance. So we know that in KNN, everything is done by knowing the position, by knowing the nearest neighbors. So that's the reason we are calculating here the Euclidean distance. So let's calculate to understand it clearly. You can see there is this graph given of height and weight, and the unknown point is red here. Okay, and we can see there are blue and there are purple points. So we'll calculate the distance. Okay, you can see we have calculated distance for three different values. Uh, in the same way, we'll calculate the distance for all the values, all the values that are given. So you can see here the Euclidean distance is calculated. It's 6.7, 13, 13.4, and it goes on. Okay. So now the rule comes is what will be the value of k. So here we are considering the value of k to be 3. Why 3? You can ask, you can calculate the number of data points. Okay, so it will be 9. Okay, so and square root of 9 is 3. That's the reason we are selecting k equal to 3 here. So as the algorithm suggests, as the algorithm is, we have to consider the nearest neighbors. So nearest neighbor means which have the minimum Euclidean distance. So you can see 1.4, 3, and 2. These are the minimum Euclidean distance value. So these will be our three nearest neighbors. And now, as you can see, these three neighbors, they are in the class of normal. So since all the three are pointing towards the normal, there is no thing to we consider it as underweight. It will obviously be normal since all the three are normal. So hence, as per KNN, the class of 57 1, 170, which was given to be determined, should be normal. Okay, so this is the industrial application of KNN. You can see this is a picture of Amazon ordering a phone. So how do these companies use KNN? So KNN plays a very important role in this online companies, or you can see where in ads also, where in when you open a particular site, you get different kinds of ads. When you open an e-commerce site, you get different kind of recommendations. So how they are using the KNN is when you select a particular phone, so you get the below there are recommendations, that shows sometimes key users have bought this, users have other users who are looking for this have bought this. So the one of the most important point is this is a fact that Amazon earns 35% from these recommendations. So KNN plays a huge role in this e-commerce sites. So what the e-commerce, what it does is, you are given a particular phone. Okay, you have selected a particular phone, so it applies KNN there, and all the phones that are similar to it, which are basically the nearest neighbors to it, which are similar in features, you may consider, or price. There are various factors, so according to that the result comes out, which is filtered result, which will have the nearest neighbors to the phones. Okay, and you can see also when you order a particular product, there is an option that users have bought this product along with this product. Okay, so all these things, all the things you see, these kind of things, all they are done by the use of KNN. So KNN is really a big thing for the e-commerce industry, and it's really important. Thank you.